Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
Pressure testing of equipment, systems and pipelines. Introduction and general philosophy. Pressure testing of equipment, system and pipelines is carried out to prove the strength of equipment designed to contain pressure or a fluid head or both. It may also be employed to check equipment, piping for leaks or conditioning favorable stresses. The adequacy of testing procedure is generally outlined with the following considerations. Basing the test pressure on the weakest member. Observing allowable stress in relation to a. Minimum metal design temperature, b. Joint efficiency, c. Area classification, design factor, d. Minimum specified yield strength value. Selection and treatment of testing medium. Temperature of the test medium and the ambient temperature. Installation of adequate pressure, vacuum relieving devices. Proper support of the equipment, system under test. Accuracy of pressure gauges and its proper calibration. Installing pressure gauges at the lowest location to account for fluid head and monitoring during the test period. Installing pressure gauge at the highest location to meet the proof test pressure. Proper sizing of blinds and spades in accordance with ASM Sect. 8, Division 1, UG 34. Proper venting. Correct pressure increase during test schedule. Mechanical clearance of all works. Competent supervision. Pressure testing of relevant segment rather than entire system. Inadequate testing procedures may result in damage to equipment, personal injury, loss of life or property in addition to time and cost impact. These losses may not necessarily be confined to the actual equipment under test and to the personnel directly involved in the test. The following considerations towards pressure test failure must be kept in view. A. The magnitude of loss during pressure test is generally a function of energy stored in the equipment under test along with secondary effects on failure of equipments in hazardous service. B. The stored energy due to pressurized fluid may be considered as proportional to the pressure or head in addition to the fluid volume under test. C. For the same pressure and volume, the energy stored in equipment under pneumatic pressure will be much higher, 200 times, than hydrostatic pressure. The pneumatic pressure test must have approval from team leader, inspection and corrosion. The likelihood of a test failure is dependent on stress levels and on the presence of any local defect or weakness. Whilst stress levels can be readily determined, however, it will be difficult to rule out the presence of weakness or defects in the system. It is mandatory to ensure proper material handling and following considerations to be met. A. The material shall be procured from company's approved manufacturers list. B. Full technical detail in confirmation to material specification shall be made available. C. The company can send its representative to witness all or part of inspection and testing activity during manufacturing or assembly phase, as deemed essential to ensure the equipment integrity and functional reliability. D. The fabrication work shall commence only after quality assurance of material and workmanship. E. The following documents are to be submitted prior to commencing any pressure test. Material test certificate including material identification. The inspection report witnessed by company representative during manufacturing and assembly. All NDT, non-destructive test, reports. Pneumatic testing. Pneumatic testing shall be considered only under following circumstances and with prior approval from team leader, inspection and corrosion. A. Where strength has been satisfactorily proven by a prior hydrostatic test and it is necessary to pressure test the same by pneumatic pressure. B. Where the equipment cannot be safely filled with liquid. C. Where trace liquids cannot be tolerated and their complete removal is considered impractical. The test area shall be clear from any obstructions and cordoned off to prevent any unauthorized intrusion. The cooling effect due to temperature reduction while depressurizing the system shall be taken into account, addressing the risk of brittle fracture. The pressurization procedure as listed hereunder shall be taken into consideration. The equipment shall be gradually pressurized up to 50% of test pressure and allowed to stabilize. Thereafter the pressure shall be increased in stages at 1/10 of test pressure each time, along with stabilizing period in between. The test pressure shall be constantly monitored and controlled safely. General test procedure. The following precautions shall be kept in view during general test procedure. The pressure testing shall not be carried out with valves closed for the system. A dead weight tester shall be utilized to cross-check the pressure gauge reading. The test pressure shall be monitored with a minimum of 1 gauge at the pressurizing source and 1 each at extreme end, the highest and lowest point of the equipment, system under test. The pressure relieving device, PRV, installed on the equipment, system under test, shall be set at the maximum allowed test pressure. All pumps, compressors to be utilized for pressure testing shall be of suitable pressure and capacity ratings. The pressure gauges shall have rating and range more than 1.5 to 2.0 times the test pressure. The halides content of the testing medium shall not be more than 25 parts per million for the testing of stainless steel equipment system. The test procedure and the package shall be approved by the company prior to commencing any pressure test. Once the test pressure is attained and stabilized, all pumping connection and accessories shall be disconnected after safe depressurizing. Test fluid. Consideration should be given to the possibility that supports may not have been designed for the weight of test liquid. Flammable gas should never be used for pressure or leak testing purposes. The use of flammable liquids should be avoided if possible. The flash points should exceed by an ample margin of the maximum surface temperature of the equipment under test and in any case must be not less than 50 degrees Celsius. The boiling point must be well in excess of test temperature. Consideration should be given to corrosive and other potentially detrimental effects on materials of construction. Whilst not affecting safety during the test, the safety of future operations may be compromised by a leak or failure caused by using an unsuitable test medium. When testing to high pressures pneumatically, an inert gas must be used if there is any possibility of a flammable material being present. This is to avoid the possibility of internal compression ignition. High pressure or vacuum. Whenever the pressurizing source has the capability of applying a pressure higher than the code test pressure, consideration should be given to the provision of a pressure relieving device. When this situation arises in hydrostatic testing, the need for a relief device should be assessed on the basis of the degree of pressure control attainable and the value of the equipment under test. A relief valve should always be used when this situation arises with pneumatic testing because of the greater potential hazard. A pressure-reducing valve may also be desirable for pneumatic testing, but this would not obviate the need for a suitably sized relief device. It is absolutely imperative that tank vents are open and clear when emptying after test to avoid creation of a vacuum. It is also imperative that competent personnel are in attendance whilst tank vents are closed during a test, since these would need to be opened in the event of a loss of liquid for any reason. Condition of equipment. Condition of equipment should be assessed by referring to previous maintenance or status record as well as through physical inspection at site. However, when applying high-pressure pneumatic testing, a thorough inspection should be performed immediately prior to the test, and supplementary non-destructive testing will often be advisable. The need for temporary restraint of bellows or other expansion joints and spring supports should be assessed. Whenever possible, manufacturers' recommendations should be consulted. Properties of materials of construction. The primary considerations are that materials should not be subject to excessive stresses and they should not be highly stressed at temperatures approaching those at which brittle fracture may occur. Reference should be made to design and construction data. The possibility that the equipment may have been modified or that components may have been replaced by inferior materials should also be considered. The possibility of brittle fracture during testing should be considered. Although the potential for this type of failure is low in Kuwait's climate, thick-walled vessels may still be vulnerable and materials of construction of older equipment may have inherently poor toughness. Heated test water may be desirable in isolated cases in winter. Equipment volume. Test termination blinds should be located as close as practical to the equipment under test in order to minimize the test volume. Technical procedures. Testing against closed valves should only be carried out when unavoidable, for example against butt-welded or socket-welded valves and wafer-type butterfly valves. In any case, this technique may only be utilized for piping and not for equipment items. The seat rating of the valve must not be exceeded. The UN pressurized side of the valve should be vented. It should be ascertained that test fittings such as spades, blinds, hoses etc. are adequate for the test pressure and that a full complement of bolts of the correct grade is provided for all pressure flanges. Fittings, which are not stamped with a pressure rating, should be treated with suspicion. Before pneumatic testing or pipeline testing, hoses and screwed fittings should as a minimum be visually examined and it may be prudent to seal weld screwed joints where practical. A suitably calibrated gauge should be used and there must be no intervening valves between the gauge and the equipment under test. A gauge should not be used if there is any doubt about its accuracy or functional condition. The gauge must be clearly visible to the operator controlling the pressure. Where permanently installed relief valves would lift under test conditions, they should normally be removed and blanked. Under no circumstances must the stem be gagged or the adjuster tampered with to prevent lifting. Spades should be avoided in relief lines, as failure to remove them after test would render relief valves inoperative in future service. Bursting disc should always be removed prior to testing. Before filling equipment with liquid, the arrangement should be checked to ensure that all air can be vented. In addition to aiding leak detection, this also serves to minimize the energy stored and the potential hazard. When testing piping systems, due note should be taken of any check or non-return valves. The test procedure must ensure that pressurization is applied where required and that depressurization of all section is achieved before opening after test. To avoid undue stresses from temperature gradients, test fluid and equipment should be allowed to reach the same temperature before pressurization. It is always desirable to pressurize slowly or incrementally. This is particularly important when pressure or volumes are high. It is also important to apply this technique to the filling of tanks and to monitor settlement when filling a new tank for the first time. Screwed plugs and connections should never be tightened during pressurization as these may blow out or otherwise fail. For hydrostatic testing only, flange bolts may be tightened to a reasonable degree but excessive force should not be applied. The specified test pressure should never be exceeded by a significant amount. It is dangerous and unnecessary to apply extra pressure in the belief that this will give a better test. It is also dangerous and unnecessary to apply any form of shock loading, such as hammer testing, during examination of equipment under test. Test pumps shall be disconnected when unattended for any appreciable length of time, however for brief unattended period, valve isolation will suffice. Competent supervision. It is important that competent personnel supervise all stages of testing. In addition, it will often be necessary for tests to be witnessed to satisfy contractual requirements or internal instructions or procedures. Apart from providing data on the condition of equipment as mentioned above, inspection and corrosion teams shall provide guidance on the mechanical properties of construction materials and also to establish a suitable test pressures.
Please give comment and suggestions.
Thank you.
Subscribe our YouTube channel and hit the bell icon for more updates. Thank for visit our channel. See you next class.
Thank you.
Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.